Greetings, boys and girls. In today's video, we are going to be reviewing area, perimeter, and volume, and this is part 2. All right, let's get into it. You guys know I love looking at this reference, the STAR reference material sheet, because it gives us formulas for perimeter, formulas for area, and formulas for volume. Okay, so I don't have to memorize these. I can see that the perimeter of a square would be 4 times the length of a side. Perimeter of a rectangle would be 2 times the length plus 2 times the width. The area of a square would be multiplying the side times the side. And then the area of a rectangle would be multiplying length times width. The volume of a cube can be found by multiplying the side length times the side length times the side length. And then the volume of a rectangular prism can be found by multiplying the length times the width times the height. Let's look at our first problem. Which equation shows how to find the volume of the model? So volume. I know that my formula is length times width times height. So now I'm going to plug these in. So that would be 8 times, my 8 doesn't look so great. 5 is my width, times, goes up 4, it's a height of 4, times 4. So now I'm going to look and see which equation matches that. In the first equation, it says 8 times 5. They're only multiplying 2 of the numbers, and that would give me the area of the base. So that is not my correct answer. Answer choice B is looking at 2 times 8, which is the length, plus 2 times 5, which is the width. Now that is actually the formula for finding perimeter. So I know that's not it, because I'm still trying to find the volume. C multiplies 8 times 5 times 4, which is exactly what I did. So I think that's it. And finally, D adds 8 plus 5 plus 4. Wait, when do we ever add 3 numbers like that? We'd add for perimeter, but we're looking for volume. So that is not it. So I can verify that this is correct by multiplying these myself. 8 times 5 would be 40, and then 40 times 4 would be 160. That's exactly what they got, so C is the correct answer. Okay, let's look at another problem. Number 9. Sanaya has a rectangular bulletin board that is 3 feet long and 2 feet wide. She wants to cover the board with felt. And she's going to do something else. Add a satin ribbon around the border of the bulletin board. How much felt and ribbon does Sanaya need? Okay, when I see that we are covering the bulletin board, I realize that they are looking for area. Okay, anytime we're covering something, that's area. So I know area is found by multiplying length times width. So looking at my problem, I would simply multiply 3 feet times 2 feet, which would give me 6 feet squared, or 6 square feet. Okay? Then it tells me that I'm looking at putting some ribbon around the border. I know that that is a perimeter situation. Putting anything around the border, around the edge, that's perimeter. So perimeter is found by multiplying 2 times the length plus 2 times the width. So let's plug in our numbers. That would be 2 times 3 plus 2 times 2, because my width is 2 feet. 6 plus 4 would equal 10 feet. So perimeter is a one-dimensional measure. It's like thinking of a line of something. So it's not feet squared, it's just feet. Okay? So the perimeter is going to have ribbon, that's for the ribbon, and the felt, I'm confirming as I read it, she wants to cover the board with felt. So the felt is what we found with the area. So now let's see if we can see 6 square feet of felt and 10 feet of felt. Now this answer choice has 6 feet of felt. Answer choice B has 6 square feet of felt, and answer choice D has 6 square feet of felt. A has 6 feet of felt, but they don't have the square, so I'm going to get rid of that one, because if they're just talking about 6 feet of felt, it could be just a line of it. It's not a two-dimensional idea, okay? It's not going to be like a piece of paper or something flat. Now let's look and see if we have 10 feet of ribbon. I see 10 feet of ribbon here and 10 feet of ribbon here. That's 6 feet of ribbon, 5 feet of ribbon. So the only answer choice that had both things I needed was B. Some people may have selected A because they didn't pay attention to the square feet, but B was the best answer choice. Press pause if I'm moving too quickly. Otherwise, we're going to move on to the next question. Hickam buys a rectangular sheet of plywood that measures 18 square meters. Oh, they told us square meters. They actually gave us the area. We know that the area is 18 square meters. The sheet of plywood is 3 meters long. Okay, so they gave us the length. The length is 3. What is the perimeter? The perimeter of the sheet of plywood. So now they want us to make another calculation. Now to figure out the perimeter, I know I'm going to multiply 2 times L plus 2 times W. But I don't have the width yet. So I'm going to go back to this problem. I know I have the area, 18 meters squared, and the length is 3 meters. And I know there's a formula, area equals length times width. So let's plug in the numbers that we have. 18 equals 3 times something, times the width. What could I multiply by 3 to get 18? Oh, 6. So the width would have to be 6 meters. And I already knew my length was 3 meters. Now I can plug these numbers into my perimeter formula so that I can find the perimeter. 2 times the length of 3 plus 2 times the width of 6. Well, that equals 6 plus 2 times 6 is 12. 6 plus 12 would be 18. Now we're talking about perimeter. It's a one-dimensional concept. It's just going around. So that would be 18 meters. Okay? Now look, one choice is meters, the other is square meters. 18 square meters is the area, not the perimeter. So we just need 18 meters. Excellent. Press pause if you need to. Otherwise, we're going to move on to the next problem. Melinda is making a tin box shaped like a rectangular prism. For the base, it's the bottom of it, she cuts out a square with a side length of 12. So this is going to be at the bottom of my rectangular prism. If Melinda wants the volume of the tin box, everything in here, to be 1,440 cubic inches, how tall should the box be? So now I'm figuring out the height, which I can think of as this part right here. I know my box looks a little sideways because of how I drew the base, but I want us to see the numbers. So we're trying to figure out the height. All right, so we're going to take it one step at a time. The first thing is I'm going to figure out the area of the base, because this would be, I know that volume equals length times width times height, but I also know that volume equals base times height. So if I figure out the area of the base, then I know one number. So they told me that I want a volume of 1,440 inches cubed, and I know that the base is 12 times 12. So that means 1,440 equals 144 times h. Look at these numbers. I think I know something looking at these numbers. That is not a decimal point. What I know is that 1,440 is 10 times as much as 144. So that means that this height has got to be 10 inches. Because if I multiplied 10 times 144, I would get to 1,440. So the correct answer would be C, 10 inches. All right. We have one more problem to look at, and that's this one. Duval has a rectangular patio that is 15 feet long and 5 feet wide. If Duval uses square tiles with a side length of 1 foot, how many tiles will he need to cover the patio? Well, we're covering the patio. This lets me know that this is an area problem. And remember, our formula for area is length times width. So I first want to figure out the square footage of the actual patio. So that's going to be 15 times 5. I've seen this so many times. I know that that is 75 square feet. Okay, so now they're asking how many tiles will he need? Well, each tile has a length of 1 foot and they're square tiles, so that means that the area of each tile is 1 square foot. So if I need 75 square feet, he will need 75 tiles. Okay? Well, boys and girls, in today's video, I just want to re-emphasize the importance of these formulas. You see that I continue to rewrite these formulas over and over because this is how I'm getting the answer. I'm not making up stuff. I'm using these formulas, and then I can turn the formulas into an equation if they give me the volume or they give me the area and ask me to find something else. Okay, so this is super useful. I hope this video helped, and until we meet again, take care.